6. We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
They have the first civilian, non-trained, a teacher. They
Roll
took
program confirmed.
a big honor. They took
Challenger
this
heading
teacher to go on
downrange.
this flight. I've seen this clip probably 3,000 times. If you were alive,
Yeah, just getting throttling down now.
saw it
At
like
94%.
every day, all day,
Normal throttles
forever.
for most of the flight, 104%.
Why have you watched it so many times?
Listen to the commentator.
We'll throttle down
Buzz.
to 65%.
They don't
shortly.
react at all. Maybe they're trained to be that way.
Engines at 65%. 3 engines running normally. 3 good fuel cells.
Did that
3
happen?
APUs.
No, they realize.
They don't seem
Velocity
to.
2,257 feet per second. Altitude 4.3 nautical miles. Downrange distance 3 nautical
They
miles.
said engine 60%.
So the 25th Space Shuttle mission is now on the way after more delays than NASA cares to count. This morning it looked as though they were not going to be able to get off.
There. Did you see that?
1 minute 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles.
They don't say a word. That crazy clown is still in my dreams.
Looks like a couple of the solid rocket boosters blew away from the side of the shuttle in an explosion.
See how non-reactive they are?
Yeah, why are they not reacting at all?
Flight controllers here looking very carefully at the situation. Obviously a major malfunction.
Obviously a major malfunction. That is very sad. So we're going to talk about the probabilities on that exact thing. So
That's so
sad day, isn't it? It's been with princess and now lost astronauts. Alright. Turns out on every shuttle, at least in those days, there were 6 O-rings. Do you remember hearing about those? I don't know. You've heard
Yeah,
about
I
this
knew all
accident
about
before?
rocket science back then.
So there were 6 O-rings. So we have on our notes here about them. And each O-ring has to work correctly, every single one of them, and they are independent of one another. So the probability of one O-ring by its lonesome, okay, we can take this again.
Okay, I
Alright.
started the video
Okay.
so she could see what happened.
Did you? Good. All right, but that's perfect. So there's 6 O-rings. They all function independently, and the probability of one of them working correctly is 0.977. And they're independent. So what's the probability that the first O-ring works, the second, the third, the fourth, up to 6? Could you calculate that for me with the fact that when one works is 0.977, which is a very high
How many are there?
probability. So there's 6 O-rings, and it's on your notes there. 0.977
87%.
is the probability that one functions. So according to independent events rule, the probability of the first O-ring working will be multiplied times the probability of the second times the multiplying times the probability of the third, and so on. So you got to take that 0.977 times itself 6 times. Kind of amazing result. What is the final when you do that? When you do
87%.
0.977 raised to the 7th, base 6th, basically. What do you get? Can you
80.
tap that out?
87%.
87%. That means then 13% of the time it's going to be unsuccessful. After this mission, NASA said that is not acceptable. And they no longer put anyone into space under those percentages. Would you like to go into space knowing 13 out of 100 are going to fail?
No.
That's way too high for an unsuccessful mission. So they changed a lot of things after that. Yes.
Even said in the video how many delays they were having.
I know.
Like, you think, I mean, with something that dangerous, you would think that at a certain point, like, I understand they spent a lot of money on the program, but for human safety, you think they would just call it.
Right. I don't know if they ever would have noticed those O-rings. I couldn't really say. All right. So statistic comes out now and saves future astronauts. All right.
Well, what did they do about it? I mean,
what did
didn't
they do about
didn't necessarily
the
save anybody. It just showed that, oh, this isn't that surprising.
Yeah, I know, but I don't think they realized. I don't think they put that
Well, I
together
think-
before.
NASA
So-
scientists probably could.
All right. Our
That's
next
right.
topic for today, a little more cheery, is the word at least one. The probability at least one will show up in our work today and continue to. So the
Wait, I'm
probability
confused.
that at least one of something happens means that probability at least
Use
one.
a marker on the front side of her page.
Can you put that in your own
She didn't know
words
she was using a
without
marker?
saying the
She just
probability
said
of
one
at
marker.
least one? How can we reword that? Can you try, Elena? If I said the probability of at least one, say that you got a
confused.
box
What-
of chocolates and you hate chocolate-covered cherries, say. So what's the probability of at least one chocolate-covered cherry being in the box? How can we say that another way with words?
I found a purple chocolate on the ground.
Oh, thank you. You think of another way, Elena, that we could say that. The probability of at least one. So what would you look for in your chocolate box? We'll put it that way.
What if it's like a box? All of them.
Didn't you do the homework?
No, because if you said at least one, there could be one, right? Or how many? One or
All of them.
or all or what else?
Or some.
Or some, right. So another way, there could be one, there could be two, there could be three. And so another way of saying at least one is one or more. Is this another way of saying the same thing? It's very hard with probabilities, though, to say how many chocolates are in a box. I don't know, 15? I don't know. So it depends on the box. Say there's 15 in this box, you'd have to do the probability 15 different times. So there's a much easier way of looking at least one problem. And we're going to look at it like this. It's going to be 1 minus the probability. We're going to say, what's the complement of at least one? Can you think of what the complement? That means not at least one. What would that look like?
Nothing.
Nothing. So it's much easier to find the probability of none occurring and then to subtract it from one. So you have a little blanks in your notes there. Please write that in one of them. So the probability of at least one is 1 minus the probability of none occurring. Let's do an example. There's a country where they have lots of HIV, another cheery topic. In this certain country, 69% of those tested for HIV do not return to get the results. It's sort of like, I decided I don't want to know, so 69% of them take the test.
Why wouldn't you just say that before you go and you take the test?
I don't know. Maybe the reality of the situation hits you and you actually take the test and you really don't want to know because HIV lurks in you for a long time before you even deal with it. So maybe I'd just rather not know. I don't know what your thinking is, but it's the truth. 69% of those tested did not return for the results because it took a long time, a week or two. Now they decided, well, we'll make these quick results tests. See where I am on the back? This problem is described. A quick result test yields, when they use the quick results, 99% of them will get the results of their tests because it's instant, pretty much instant. However, the quick tests aren't as accurate as the long tests. So,
By 0.004.
yeah, it has a chance of 0.004 chance of producing a false positive. Could you write down in that blank what a false positive would mean in this situation? What is a false positive? It's because you have false positives and then you also have, oh, never mind, I won't confuse it. Let's just stick with false positive. Brandon, what would you write in there for
Well, I
false
had a
positive?
question. I had a question for this. I thought it said like 99% to get to obtain the results, like the other 1% had to leave in like 5 minutes.
I know, they just ran out the door, you know, so I don't want to know. Why did you come today? All right.
Okay, so I'm sorry, you said
Took the
false
test,
positive?
ran out the door.
Yeah, or maybe they fainted. They said, I can't take the stress. They fainted. However, the quick results test had a .004 chance of producing a false positive.
Telling
So-
that means telling you that it's positive when it's not.
Right, so
Yes.
that's what you
False.
put in that blank. That means it's telling you you have HIV, and guess what? You don't. That's kind of nasty, but it happens with this kit. .004% of the time, or not percent. The percent would be 0.4% of the time. What's the chance of 200 people tested that at least one is a false positive? So you said this is an example of this at least one chocolate problem. All right, so we are going to think of it in this way with the complement. The probability of false positive being greater than or equal to 1 is going to be 1 minus its complement. What is the complement of at least one false positive?
No false.
No false positives. So that means they all work correctly. All kits work correctly. Where could I go to get that probability? I know that .004 fail, give me a false positive, so how many work correctly? Will I not take the .004 and do what with it? Brandon, what will I do if .004 fail? How many correctly give me the results? What will I do with that .004 to find the number? Ideas? Caleb?
Oh, I'm not sure.
If .004 work, where do I find its complement? How many, I mean, .004 fail, how would I find this complement? How many
Subtract it
work
from
correctly?
one.
Subtract from 1.
Okay.
Okay, so we
I
have,
thought you said
Do you
something.
have to? You're gonna subtract that from 1 now?
yep, now.
Okay, do you
yeah,
wanna
we're
end
not
this?
quite, because now we're not to this one yet. This is a different one. So we're going to find the probability that all the kits work correctly. This is the ones that don't. So we take this from 1 to get .996. That's for one kit to work correctly. But how many kits are we working with today? 200 people came in. So we're going to have to do .996 times .996 times .996. We're going to have to do that 200 times. So that's
44
0.9.
Miss
8%?
Pat, do you want to end this? The timer went off.
That can't be right.
What happened?
The timer went off.
Okay.
Okay.
Shut it down.
Okay.